In today's video, we're going to be looking at how to solve modulus equations and modulus inequalities. So here's an example of a modulus equation, first of all. Now, every time we do these, there's going to be two types of modulus questions that we can be looking at. Okay, there can be a question that involves a modulus where the answer is a number, like in this question here where it just equals a 10 on the other side. If that's the case, you're going to be looking at a very simple solution. If, however, the left-hand side contains the unknown x and the right-hand side contains an unknown x, then what we should also do, if the question doesn't already tell us, is to draw a sketch to make sure that the solution that we've got actually works. Sometimes what we'll find is we can solve a modulus equation, but the answer that we obtain might not necessarily work when we plug it back in. Okay, so as I said, these first ones though, where it equals a number, these ones should be quite straightforward for you. So this question here just says the modulus of something when we subtract 7 equals 10. So straight away we know that this thing here needs to equal 17, because 17 take away 7 equals 10. So now we just need to think about, well, the modulus of which value or values will equal 17. Well, we know 17 works straight away. The magnitude, the size of 17 is 17. Or x could equal negative 17, as negative 17 also has size of 17. So we have two solutions for this question. So for example 2, what we've now got is we've got a modulus of a full function on the left-hand side equaling a single value on the other one. So hopefully it's going to be another straightforward question. And there's two different ways we can actually tackle this question. The first one is by trying to treat it as two separate equations. The second method involves squaring both sides, which I'll explain why in a second we can do it like that. So if I just write out the equation that we're solving here, we want the modulus of x minus 1 to equal 4. That means this thing here needs to have size 4, so it's either going to be 4 or it's going to be minus 4. And what we do is we write out both those different equations. So we want x minus 1 to equal 4, or we want x minus 1 to equal negative 4. And if we solve the top one, we get 5. And if we solve the bottom one, we get minus 3. Now, depending on how complex this actual equation is, would tell us whether we should probably be looking at method 1 or method 2. This is quite a straightforward one. There was nothing really challenging about this one, which is why I think this method here would probably be the one that I would have done. But method 2 also works if it starts getting a little bit more awkward. So at the moment, we don't know if this x minus 1 here is a positive value or if it's a negative value. We don't know if it equaled 4 or if it equals minus 4. But what we could do to both sides to ensure that this left-hand side is definitely positive is to square it. And if we square the left-hand side, we'd also have to square the right-hand side. So if we square the left-hand side and get x minus 1 squared, that would equal 4 squared. And if we multiply out x minus 1 squared, we'd get x squared minus 2x plus 1 equals 16. And then we're just going to turn that into a quadratic that we can solve by moving a 16 across as a subtract 16. That allows us to factorize it. And then we can solve it. And wouldn't you know, we get the same two answers from method 2 as we did with method 1. So it'll just be a case of personal preference here about which method you do. I would always try and look at the actual equation first of all, and if it looks quite simple, try method 1. If it looks like it's going to be a little bit more awkward, think about squaring both sides. And of course, only use these ideas really if the right hand side is just a single value. Because if we start getting things that look a bit like this question, we need to start thinking about sketching the graphs. So we need to sketch the x plus 3 modulus graph. We also need to sketch the 3x minus 5 modulus graph. And then we're going to look at where this inequality actually occurs. So the first thing I need to try and do is sketch the graph. So apologies if this is going to take a little bit of time. It's quite tricky to draw these on my iPad. So the first one is going to go through, if I just try and mark some key points on. This is the x plus 3 graph. So it's going to go through positive 3 and it's going to have a gradient of 1. Let's try and draw that line now. There we go, that looks okay to me. So that's just y equals x plus 3. We'll cover the modulus part in a second. And we now need to draw the 3x minus 5 graph, which I'll do in a blue. And again, I need to mark some key points. So what do we know? We know it's going to go through minus 5, and it's got a gradient of 3. So if I mark, that's in the wrong place, every third dot. There we go. Let's try and give this one a go and see what we get here. It's a little bit off, but it's not too bad. Okay, so this is the y equals x plus 3 graph. And the blue one is y equals 3x minus 5. And now we need to turn these into the modulus graphs. So we covered this in a previous video. For these functions, anything that is below the x-axis, we now need to try and reflect above the x-axis. So if we start with that red one, we need to move this part down here above the line. And again, I'm just going to quickly mark some points on. There we go. So if we draw that line there, and now I can get rid of the bottom line. Just cut a little tiny bit off. And now we've drawn that first modulus graph. And the same idea with this blue one. We now need to try and flip this bottom part down here upwards. So we're going to go through these points here that I am marking. And again, that does not look too bad at all, so I'm quite happy with that. We'll get rid of this part below the line, and I'll put my modulus signs on there. So we want the modulus of the x plus 3 graph to be bigger than the modulus of 3x minus 5. In other words, in terms of colours on screen, we want the red line to be above the blue line. And we can hopefully see that that occurs along that yellow stretch there. So now what we need to do then is we need to try and hopefully spot, or if not work out, where the blue and the red graphs actually intersect. So we can see there's an intersection point there and an intersection point down here. Now this one here looks very obvious, like it's going to be 4. This one, we could probably take a good guess at it, but we might be slightly off. We need to try and work it out somehow. However, even though this one up here we can do, I'm still going to call it 0.1, I'll call it P1, and we're going to try and find that value out. We think it's 4, but we should always try and double check using algebra. So here's my working out to try and work out where 0.1 actually is. So to work out where these cross, we need to make sure that we have the equation of the two lines that are crossing at this particular point. So first of all, what we've got is we've got this red line, which I'm now highlighting in green. That is the x plus 3 line, and it needs to cross this line here, which is 3x minus 5. Now you might think that's really obvious because those are the things in the question, but just wait until we get onto the second part and we have to think about what it is we're doing. So we're trying to solve x plus 3 equals 3x minus 5. So if we shuffle things across to the other side, we're going to get 8 equals 2x. So that's 4 equals x, or x equals 4, depending on which way you prefer to do it. So even though we looked at the graph and it crossed on the line and we thought it was 4, it was always worth double checking in case it was very slightly off. So now let's look at this second point, which I'm going to call P2, and we'll try and work out where that point is. Now again, we need to make sure we know what lines are crossing at that particular point. Again, we've got this line here, which is x plus 3. But then we've got this line, and the equation of this line here is not 3x minus 5. This line that I've just highlighted does not have a gradient of 3, nor does it cross the y-axis at minus 5. In fact, it's the exact opposite. It's got a gradient of minus 3, and it crosses the y-axis at positive 5. So actually, it's the inverse of this modulus. So the second set of equations that I need to try and solve is where x plus 3 equals minus 3x plus 5. That's going to get me 4x equals 2. So x is going to equal a half. And we might have been able to guess a half from the graph, but we should always do the algebra to work out exactly where these points are crossing. So now we know where the points are, we now need to actually answer the question, which says where is the red line, which might be tricky to see now that I've highlighted everything. Where is the red line above the blue line? It is between those points. Keep an eye on what inequality symbol it is. This is just a greater than, it is not greater than or equal. So our answer for this question is x needs to be bigger than a half, but less than 4. So same type of idea here. It says solve the inequality. Now for this question the graph was not given, but I've got the graph ready because the moment I look at that I'm thinking this is going to be quite a difficult question. We've got multiple unknowns, so we should always sketch a graph to make sure that our answer is going to be valid. If I didn't, I would get a couple of solutions for x and I might not necessarily know which one of those solutions is correct. I might even show that after I've drawn the picture. So let's start off by drawing the modulus of x minus 1 graph. So it's going to cross down here at minus 1. Let's get some points done so that when I try and freehand the straight line, I know where to start and where to finish. It's going to look something like that. And now if I do the reflection, it went a bit wobbly, but it's near enough where we need to be for this. So this is the y equals modulus of x minus 1 graph. And then the other one is just going to be the x, so the y equals 4x graph, which is going to go through these points here. Straight line tool. And again, that does not look too bad, so let's just stick with those. I'm not going to redraw any of these ones. So for this question, we want the 4x to be bigger than the modulus graph. So we can see for this one, the bit that I'm going to highlight is literally all of this part here forever. And what I need to do is I need to find that point there. In order to do that, I need to think about what lines I've got crossing at this point. I can see that I have the 4x line. This other line that we've got though is not x minus 1. It's the part that we've just reflected up, so it's going to be the inverse. It's going to be minus x plus 1. So that point there, in order to solve it, we're going to set 4x equal to minus x plus 1. And if we do that, we're going to get 5x equals 1. So x is going to equal 1/5. If this point here is 1/5 and we want that blue highlighted section, then the answer to the question is going to be x needs to be bigger than or equal to 1/5. Now let's say I didn't sketch this graph. If I try to solve it by whichever way I want to do, if I want to try and make positive 4x and negative 4x, or if I try and do the square both sides method, let's go for the square both sides method, we'd get something like this. We would get x minus 1 squared equals 4x squared. So that's going to get me an x squared minus 2x plus 1 equals 16x squared. That means we're going to get 0 equals 15x squared plus 2x minus 1. That is going to factorize. Just trying to work out what it is. It's going to be a 5x in one bracket and it's going to be a 3x in the other bracket. And we're going to get minus 1 over here and positive 1 over there. So we actually get two different solutions. We get the x equals the 1/5, but we also get x equals minus 1/3. So if we didn't draw this graph, yes, we would have got the right value at one particular part, but we might have got stuck about what this minus 1/3 actually means and where it comes in our solution. Well, the reason we get this x equals a minus 1/3 is if I was to extend that red line how it was originally, it would have crossed again at this point, and the x value of that point is minus 1/3. But in the context of the entire question, we did not actually need to use this minus 1/3. So even though the maths in the bottom right corner here is absolutely fine, when we actually put that back into the inequality at the top, our answer does not get us a valid answer. If we think about what we would have got, if I plugged that minus 1/3 into this inequality, it would have said minus 1/3 minus 1. We want the modulus of that. Is that less than or equal to 4 lots of minus 1/3? So what we're trying to work out there is the modulus of minus 4/3. Is that less than or equal to minus 4/3? And even though the numbers are the same there, the fact that the left hand side has the modulus means this negative 4/3 actually becomes a positive 4/3, and that's where the whole errors kind of kick in. So for these type of questions, always sketch a graph. Now for question 5, it says that there's a student who's attempted a question and they've done all the working out, and then you need to try and explain the error that this student has made. So you can either pause the video and have a quick think, but in about 5 seconds time I'm going to continue talking. Okay, so again, similar to the previous question, technically the maths that they've done here is absolutely fine. The mistake they made was they didn't draw the graph. Just trying to move that and make it bigger. I have it in the bottom left corner all ready to go. So if we look at what the graph looks like, the modulus graph is the blue line, and then we've got y equals x is the red line, and we can actually see that these graphs never actually intersect. So there are actually no solutions that fit the inequality at the top of the screen. Again, the maths technically is fine the way they've solved it, but by not drawing the graph, they've not checked to see if the x equals -2 and the x equals -1 answers are valid answers for this question. And again, if you were to plug these numbers back in to the equation at the top of the screen, you can see why these answers are not going to work. If we look at the -2 answer, if we did 3 lots of -2 plus 4, does that equal -2? Well, inside the modulus, we get -2, but the moment we then take the modulus of that, the negative sign disappears. And what we've actually got there is 2 equals -2, which definitely is not true. And it's the same if you plug -1 into it. If you do 3 lots of -1 and add 4, and then take the modulus, what we actually get there is 1 equals -1. And again, they're not true. Again, trying to stress here, for all of these questions, sketch your graph. Now, the final one is also going to test you on how good you were with actually drawing the graphs. The graph that we need to try and draw is one of these kind of compound graphs that you need to kind of build up slowly. We need to try and draw the 4 minus 2 modulus of 2x plus 1 graph. So if you remember how we did that in the previous video, we started off by drawing the 2x plus 1 graph. Apologies again, it's going to take me a little bit of time to draw these. That's going to look something like this green line. The modulus of that, though, means that at this point we're going to flip it through the x-axis, or the negative part, and we get something that looks a bit like that. So that's y equals the modulus of 2x plus 1. The next thing we need to actually do, though, is then reflect that in the x-axis as it's a negative. So let's change the colour, and let me just again get some points drawn so that I can then draw this modulus. So the red line is the negative modulus of 2x plus 1 graph. So now let's get rid of the green part. And then finally, to finish this question off, we need to add 4. So it's going to translate the graph 4 squares in the y direction. So let's move 1, 2, 3, 4. It's going to go here. 1, 2, 3, 4. And hopefully now I can draw these. Let's go for that. There we go, it's near enough right. There we go, and I'm going to label that then as the y equals 4 minus a modulus of 2x plus 1 graph. Then it says we need to solve the equation x equals 4 minus the modulus of 2x plus 1 graph. So that's without sketching anything yet. Can we solve it? So let's have a think about how we could do that. The first thing we need to kind of do is rewrite the question. We need to move things across to the other side. So what we're going to do here is we're going to move the 2x plus 1 modulus to the left hand side, and we're going to move the x to the right hand side. So that's going to get us positive the modulus now of 2x plus 1 equals 4 minus x. And I think maybe the best thing to do for this question would be to square both sides. So if I square the left hand side, I'm going to get 4x squared plus 4x plus 1. And if I square the right hand side, I'm going to get 16 minus 8x plus x squared. Now let's move everything across to one side. We're going to get 3x squared plus 12x minus 15 equals 0. To make it easy for myself, I'm going to divide everything by 3. And now we can factorize it. So it's going to be x plus 5, x minus 1 equals 0. So x is going to equal minus 5 or x equals 1. And what I should maybe do at this point now is to draw the y equals x line on my diagram, and hopefully, if I've done it right, it's going to cross at those 2 points, or at least one of those points. It could technically cross at neither of those points, in which case there would be no solutions. And I'm about to draw all the way through my working out. And you can see by where I'm putting the dots that it is actually going to cross in 2 different places. Let's just make the colour a bit easier to see when I draw the line. There we go. Let's label these graphs so we know which one's which. We've got y equals x, which is the red, and then we've got y equals 4 minus the modulus of 2x minus 1, sorry, plus 1 graph in blue. So we've solved it. We're quite happy with these answers. So my answer for part B is that green highlighted box. It then says solve the inequality where x needs to be less than 4 minus the modulus of 2x plus 1. So we want the blue line to be above the red line, which is that part there. And because we know the key points, we can now write down our final answer for this. And I'll do it up in the top left corner. So we need x to be between minus 5, not equal to, but between minus 5 and 1. So to quickly reiterate, if the question looks quite easy, we might be able to solve it without a graph. If it's a modulus equals just a single number, we probably don't need to draw a graph of those ones. The moment though we start seeing multiple x's in a question, always sketch a graph. And it's probably also worth maybe plugging numbers back into your equation at the end to see if your answer actually is a valid answer. Okay, a bit like on that question 5, because that person hadn't plugged minus 2 and minus 1 back in, they just assumed that they were correct because they didn't draw a graph as well. So always try and think of ways with these types of questions of checking how you get your answer. The graph is probably the best way of doing it. Other little techniques would be things like we did on this one. You could square both sides as well. Again, that doesn't always mean those numbers are going to be used in your answer. The graph is going to really, really help you.